Introduction of case study. The Gauss-Jordan Elimination Method is a systematic mathematical technique used to solve system of linear equation. It is an extension of Gaussian elimination, where the matrix is reduced further into reduced row echelon form (RREF) by applying elementary row operation. It is one of the most efficient methods in linear algebra because it directly provides the solution to a system without requiring additional back substitution. In this case of study, the Gauss-Jordan elimination method is applied to solve a system of linear equations accurately and efficiently. The method transforms the argumented matrix step by step until leading entry private is equal to 1, and all other entries in the corresponding column are 0, allowing the solution to be obtained directly. This case study also demonstrates how real-life problem can be represented as system of linear equation and solved using metric operation. The method provides a structured and logical approach, making it easier to analyze problem involving multiple variables. Next is purpose of study. Purpose of study Gauss-Jordan Elimination Method is to solve system of linear equation accurately and efficiently using the Gauss-Jordan Elimination Method. Second is to determine the inverse of a square matrix using the Gauss-Jordan Elimination Method. Thirdly, to understand the process of transforming an augmented matrix into reduced row echelon form (RREF) through elementary row operation. Lastly is to compare the efficiency of the Gauss-Jordan Elimination Method with other methods for solving system of linear equation.
Here, let me explain about our problem statement. There is a coffee shop that offers 3 types of coffee, which are Americano, Latte, and Cappuccino. The management wants to determine the price of each coffee types based on the total amount paid by the customers. The question is, during a special one-day promotion at a coffee shop in Arab Perlis, 3 types of coffee were offered at discounted price. The 3 types were Americano, Latte, and Cappuccino. 3 friends, Lily, Sam, and John, each bought a different combination of coffees. Lily bought 1 Americano, 1 Latte, and 1 Cappuccino for 30 ringgit. Sam bought 2 Americanos, 2 Latte, and 1 Cappuccino for 40 ringgit. And John bought 1 Americano, 3 Lattes, and 2 Cappuccinos for 65 ringgit. Based on these purchase totals, determine the individual price of each type of coffee by using the Gauss-Jordan Elimination Method.
Methodology of Gauss-Jordan. There are several steps in Gauss-Jordan Elimination Method. Step 1. Define the variable. In this step, we need to identify the unknown quantities in our problem and assign each them a variable. Step 2. Translate the problem text into the system of linear equation. For 3-variable system, we typically need 3 distinct equations, like the example below. Step 3. Transform an augmented matrix by extract the coefficient and constant from the equation. Step 4. Locate the pivot element. Starting with column 1, the pivot element is the diagonal entry of that column, such as, for column 1, the pivot location is row 1, column 1. Step 5. Create a leading one. The pivot elements need to be exactly 1. If it isn't, we need to use the elementary row operation to make it 1 by swapping or scaling method. Swapping is the method that swaps the current row with a row below it that already has value 1 or a covalent number in that column, while scaling is the method that multiply or divide the entire pivot row by a constant scalar to force the pivot to become 1. Step 6. Clear other elements in that column by turning them into 0. This applies to both below and above the pivot. Lastly, repeat the process for other remaining columns so our matrix will reach a reduced row echelon form. It will look like an identity matrix on the left side.
The solution for this question, first we use the step 1. Let Americano equal to X, Latte equal to Y, and Cappuccino equal to Z. Following the step 2, the new equation are X plus Y plus Z equal to 30, 2X plus Y plus Z equal to 40, and X plus 3Y plus 2Z equal to 65. For step 3, we change the equation into the augmented matrix. For step 4, we start use operation row 2 minus 2 row 1 to get new row 2. Other than that, we use row 3 minus row 1 to get new row 3. This will turn the 0 on the leading one in column 1. After that, we use operation minus row 2 to get new row 2. So it will turn the leading one in column 2, row 2. After that, we use two operations. First, row 1 minus row 2 to get new row 1. Second is row 3 minus 2 row 2 to get new row 3. So it will clean 0 for up and under leading one in column 2. After that, we use operation minus row 3 to get new row 3 to get new leading one for column 3. After that, we turn 1 into 0 using operation row 2 minus row 3 to get the new row 3. So we get a cleanup identity such in a step 6. After that, we turn it into SLE. X equal to 10, Y equal to 15, and Z equal to 5. So this is the final answer for this equation. For the result, based on the Gauss-Jordan Elimination Method, the value of price for each type of coffees was successfully determined from the system of linear equation. The final answer obtained are Americano, which is X, equal to Rm 10 ringgit, Latte, which is Y, equal to Rm 50 ringgit, Cappuccino, which is Z, equal to Rm 5 ringgit. This means the price for one Americano is Rm 10, price for one latte is Rm 15 ringgit, and price for one cappuccino is 5 ringgit.
From our study, we successfully applied the Gauss-Jordan Elimination Method to solve a real-life problem involving the pricing of coffee products during a promotional event. By constructing a system of linear equations based on the purchases made by Lily, Sam, and John, we were able to determine the individual prices of Americano, Latte, and Cappuccino. The results shows that the price of an Americano is 10 ringgit, a latte is 15 ringgit, and a cappuccino is 5 ringgit. These values satisfy all three purchases, totals of 30 ringgit, 40 ringgit, and 65 ringgit made by the three customers, confirming the accuracy of the solution obtained. This study highlights the importance of linear algebra in solving real-world problems. The Gauss-Jordan Elimination Method provides an efficient way to determine unknown values from multiple equations. Therefore, mathematical concepts such as linear algebra can be applied successfully to everyday business and pricing problems. This case study successfully applied Gauss-Jordan elimination to determine the individual prices of Americano, Latte, and Cappuccino. By converting the problem into a system of linear equations and solving it systematically, the exact price of each coffee were identified effectively. This project demonstrates how mathematical techniques, particularly the Gauss-Jordan Elimination Method, can be used to solve real-life problems accurately and efficiently. The method provides a clear process for finding unknown values and verifying the correctness of the solution. Therefore, it is useful tool for solving practical problems involving multiple variables and linear equations in everyday situations.